Hello, 8th grade. We're going on to the next section of science, 4.2.2, forms of energy. And so we are on page 233 in your reading book. Forms of energy. Objectives for this chapter. Identify various forms of energy. Explain the transfer of energy in a given system. Calculate kinetic and gravitational potential energy. The whole stadium feels tense with the strain of the crowd, watching and waiting, as the timer counts down the final moments of the game. The teams have been tied at 2-2 since the first quarter. With 10 seconds left on the clock, a player in red blasts through the defense and scores. The crowd goes wild and the stadium erupts with deafening cheers. The home team has triumphed. You, however, missed the excitement. You have just returned from the concession stand, and all you see is the ball rolling out of the goal. That's a shame. What actually happened before that? What did it take for the ball to roll out of the net? Where did the ball get the energy to move? The net transferred its elastic potential energy to the ball. Before that, the ball flew into the net and transferred its kinetic energy to the net. The soccer player's kick, he kicked the ball using his mechanical energy to move the ball. The player ate a big bowl of pasta before the game, taking the chemical energy of his food and converting it to thermal energy to heat his body, electrical energy to control his nervous system, and mechanical energy to move his muscles. Where did his food get the energy? The pasta is made from grains that get energy from the sun. The meat on the pasta came from the animals that eat the grain that get their energy from the sun. Nuclear fusion creates the radiant energy released from the sun. Energy has many forms, and it's useful not only because of the many forms in which it is found, but also because of the original forms that can be converted. This means that energy has many practical uses. Chemical potential energy. Chemical potential energy is stored in the chemical bonds that hold atoms together in molecules. For example, energy stored in gasoline can be converted by combustion, or burning, into kinetic energy to move a car. Burning wood provides thermal energy to cook food. Chemical energy in food changes into thermal, electrical, and kinetic energy for the body's use. Elastic potential energy. Elastic potential energy is stored in a stretched spring or other elastic object. Elastic bands and diving boards have this type of energy when they are stretched or deflected. When the diver bounces on the board, the elastic energy of the board is returned to the diver, giving her the kinetic energy she needs for the dive. Same thing with trampolines. If you were to jump on the grass, you would jump and that energy would be absorbed by the ground and you wouldn't go anywhere else. Whereas if you jumped on a trampoline, that trampoline has elasticity to it, and so your kinetic or movement energy is being transferred to the potential energy of the elasticity of the trampoline, which is then shot back into you as kinetic energy. And then that potential elastic energy then becomes elastic kinetic energy, and that rockets you, depending on how hard you jumped on your trampoline, will determine how high you end up bouncing off of the trampoline. Gravitational potential energy is stored in an object that has been lifted to some height. The greater the height, the greater the potential energy. Waterfalls convert gravitational potential energy into kinetic energy as the water falls. Hydroelectric facilities change the kinetic energy into an electrical energy. And so if you have the Hoover Dam is a hydroelectric facility, and so it uses the flow of water over gears or over a machine that then collects that kinetic energy from the movement of the water and that gravitational pull pulling it down with force into electrical energy, which then supplies our electricity. Electrical energy is kinetic energy of electrons. The attraction and repulsion of electrical charges causes electrons to move. Their energy can be transferred to kinetic energy for motors in DVD players, blenders, and power tools. So that electrical energy, once you press on, is turned into kinetic energy, which makes your machinery work. And thank goodness it does. Radiant energy from the sun allows plants to create chemical energy through a process of photosynthesis, which they store in starch. The energy from the sun also provides light and warmth and can be converted into electrical energy. Solar energy provides a renewable resource. I know some of you have solar panels on the top of your house, and that solar energy that is collected is then turned into electrical energy, which can then power your house, which is pretty awesome. Back on the other page, for your information, wind-up toys. How many of you have ever used a wind-up toy before? What do a robot, a bird, and a monkey all have in common? They can be made into wind-up toys along with the hundreds of other mobile objects and animals. Wind-up toys get their energy by moving a spring being wound up, which builds up elastic potential energy. Mechanical energy is used to wind the spring. The more it is wound, the more potential energy it has. When the key is released, the spring unwinds and the elastic potential energy is converted into kinetic energy so the toy can move. Same thing if you've ever had one of those pullback cars, either a Matchbox car or any little toy vehicle that you pull it back, and you can usually pull it back a few times and it stores up all of that energy, that elastic energy as you're moving it, and then when you let go of it, it is then converted into potential energy, and the spring inside or whatever gears they have inside that have been collecting all that energy then releases it and allows that car to go forward, depending on how much energy is allowed to be stored in that car and how many times or how hard you've pulled it back will determine how far it goes. Thermal energy. Thermal energy is the total kinetic energy of the atoms that make up an object. The hotter the object, the faster the atoms move, and the more kinetic energy the atoms have to use. Mechanical energy. Mechanical energy is the total of all potential and kinetic energy within an object or body. Anything or anyone that moves has mechanical energy. God designed your body to be maintained through a constant transfer of energy. The chemical potential energy in your food becomes the heat to keep your body at a constant temperature. It also becomes electrical energy that sends messages along your nerves and mechanical or muscular energy that allows your muscles to move. How does energy change from one form to another? Consider a pendulum. When the weight on the end of the string hangs straight down, the pendulum has no kinetic energy because it is not moving. It also has the minimum possible potential energy. Lifting a pendulum is work, and the pendulum gains potential energy. When the pendulum is released and begins to fall, the potential energy changes into kinetic energy. By the time the pendulum is swinging through its lowest point, all the potential energy has been converted into kinetic energy. No potential energy is left. As the pendulum swings out towards the other side, however, it slows down. As it slows down, it loses some of its kinetic energy. At this point, the kinetic energy is being transferred into potential energy. At some point, the pendulum has converted all its kinetic energy into potential energy, and it stops moving. All the energy is again potential energy, and the pendulum swings back once more. If you think about a tire swing, if you have a tire swing on a tree, not so much the one at school that just goes around in circles, But even a swing can go for this. A swing is a type of pendulum. So it has a center point and it swings in both directions from that center point. And so as the swing is sitting there without anyone touching it, it doesn't have any potential or kinetic energy because it's not moving. As you pull that swing back, it's gaining potential energy, which means it has the potential of exerting energy. And then as soon as you let go of it, that potential energy is then transferred into kinetic energy because now you are moving forward. Now, as it meets that center point again, it has used all of its kinetic energy. And as it starts going in the other direction, it is now slowing down, but it's transferring that kinetic energy into potential energy because as it goes up, it's going to stop eventually. If it just kept going with kinetic energy, the swing wouldn't stop. But because it's turned into potential energy, it's slowing that swing down until it reaches the max amount of potential energy, stops, and then it goes the other way. And as soon as it transfers from stopping position to going back the other way, that potential energy is turned into kinetic energy, and then it keeps going until it eventually comes to a stop again, and all the energy has been exerted. Now, if you are using your mechanical energy being on the swing and your electrical energy to move your body and pump your legs, you can keep the momentum of that swing and the potential and kinetic energy in that swing going because you are exerting force at a constant rate because of the energy within your body, not the energy that is in the swing. If you just took a swing with nobody on it and pulled it back and let go, it would pendulum for a while, but it would eventually slow down because it has nothing giving it more energy to move forward. And because of friction, the friction in the air that it's coming in contact with, it slows down. Okay. Science in action, the gray box on page 235. Gravitational potential energy. To calculate the potential energy of gravity, use the weight of the object in newtons and the position of the object in relation to the ground. For example, a rock with a mass of 400 kilograms sits on a cliff that is 300 meters high. What is the gravitational potential energy? So, PE equals m times g times h. M is the mass of the object. G is the acceleration rate of gravity, 9.8 meters per second squared. And then h is the height in which it would drop. PE would be the 400 kilograms times 9.8 meters per second. That would then be multiplied by 300 meters. And so that would equal 3,920 newtons times 300 meters. Which would equal 1,176,000 Newton meters, which would then be transferred to joules, and so it would be 1,176 kilojoules. And so that's how you would determine the gravitational potential energy of an object. Try this. Warming your hands. Rub your hands together quickly. Continue rubbing for as long as you can. Have another student time you. Then switch roles. What happened to the temperature of your hands? Why did that happen? Why did you finally stop rubbing your hands together? Trace the energy conversions from the food you ate to the heat energy from rubbing your hands. So if you just rub your hands together, do it for a long time. You can time each other if you're together, but just keep rubbing them. You can go in circles. That actually helps a little more. And so keep doing that, and then stop and talk about why you stopped, what you felt rubbing your hands together, what it created, and how do you think that happened. Okay, laws and principles on the bottom of page 236. Kinetic energy is the kinetic energy of a moving object equals 1/2 its mass times its velocity squared. So that formula would look like KE, kinetic energy, equals 1/2 meters times velocity squared, or mass, sorry, not meters, mass times velocity squared. So what is the kinetic energy of a 300 kilogram object traveling at an average velocity of 10 meters per second to the south? That formula would look like kinetic energy equals half of the 300 kilograms, the mass, times 10 meters per second, the velocity or the rate in which it's moving, would equal 150 kilograms times 100 meters squared by a second squared, which would equal 15,000 joules. Okay. Questions for today. Again, you do not have a lab today, so it's just answering questions. Number 1, give an example of a chemical potential energy and how it is used. 2, what is thermal energy? 3, why does a 2 kilogram book that is 3 meters off the ground hurt more when it lands on your foot than a 2 kilogram book that is 1 meter off the ground? Number 4, use the example of a pendulum to explain how energy is transferred. 5, if an arrow has a mass of 0.02 kilograms and travels north at a velocity of 65 meters per second, what is its kinetic energy? Use the formula in the box below to answer that. And then number 6, how much gravitational potential energy does a bucket with a mass of 17 kilograms have if it's sitting atop a 2-meter wall? So you're going back to Science in Action to look at the formula for gravitational potential energy. Again, give those a try. If you have questions on how to answer those, send me a message or come on at 10:30 for the normal Zoom meeting, and I can help answer those, and we can do them together then. I'll see you next time.